Greetings to all of you. In today's session, we are going to start with the chemistry, which is helpful for any entrance examination or else competitive exam you are seriously preparing for on the international floor, national level India, and within the state Telangana and Andhra Pradesh. India level, JEE Advanced and JEE Mains exam, NEET Chemistry for Medicinal Entrance Examination, Telangana EAMCET for Engineering Entrance Exam, Andhra Pradesh EAMCET exam for engineering entrance. For all these, it will be helpful. In addition to all these, this kind of content will be helpful for the competitive exams, any government examinations you are writing for. This will be very much helpful. Let's enter into our today's session. Name the following two compounds as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. As per this IUPAC, organic compounds are given. We need to assign right naming for this kind of system. Right. First compound is having methyl and chloroside chains, and this parent organic chain will be there. Here we have methyl and bromoside chains with the parent organic chains of 4 carbon. Right. So for these two compounds, what will be the right naming we need to assign? Among all, option number A is correctly explaining what are the exact names of these two compounds as per the IUPAC protocols. The names will be 3-chloro, 2-methyl pentane for compound number 1, 2-bromo, 3-methyl butane for compound number 2. Let's see how can we explain this one, right? Here, IUPAC rules are provided for alkyl halides. According to IUPAC, F for fluoro, Cl for chloro, Br for bromo, I for iodo. So this is the kind of abbreviation. And halogens are treated as the substituents on the alkyl chain. Whenever you consider alkane chain, on that halogen will be the substituent. The halo substituent is considered equal rank with alkyl. If alkyl and halo are there, both are having equal priority over there on the parent chain. Okay. So if we see these two compounds, and one more important thing we need to understand is if two similar functional groups are there, how to write, how can, with which we have to start, that will be provided with the alphabetical order, right? So in case of this one, whatever the organic compound is given to you, shortest distance can be taken as the higher priority, right? So that if you see chloro, so this side chloro will be third, this side also chloro will be third. We need to consider second substituent as well, that is methyl. If you are considering from this side, it will be 4. If you are taking from this side, it will be 2 only. No, it is the shorter distance, so that we will start numbering from this end. Okay, so here 2-methyl will be there, 3-chloro will be there, and the parent chain is having 5 carbon atoms. But in order to write its name, we have to follow alphabetical order. C will come first over M. C for chloro, M for methyl. So that 3-chloro, 2-methyl pentane will be the right naming for compound number 1. Move on to compound number 2, where you can see bromo on the second carbon, methyl on the third carbon. Among methyl and bromo, B comes first over M. That's the reason why we will start naming with the 2-bromo. And methyl will be there on the third carbon, 3-methyl. Parent chain is of 4 carbon length. So that butane will be the parent chain. This will be the 2-bromo, 3-methyl butane is the right naming for compound number 2. This is the question given from IUPAC nomenclature of organic compound. For question number 1, option number A will be the correct answer. Move on to question number 2. This is a question collected from Cambridge Assessment International Education. Find the exact graph for the instantaneous rate from the following. Instantaneous rate is nothing but the reaction which happens simultaneously, spontaneously, without any interruption. Whatever reaction carried in very short span of time is called instantaneous reaction, right? These many graphical forms are provided, which is the right representation for instantaneous rate of the reaction we need to interpret. This is the question given from chemical kinetics. In the option number 1, here P1, P2 are provided on the y coordinate, T1, T2 are provided on the x coordinate. There is a curvature, right? So, but if you are considering pressure 1, pressure 2, time 1, time 2 are present. For this kind of curvature, you have to go for average rather than instantaneous rate, because we have different kind, so that whatever value coming is the average rate of the reaction. So this may not be the correct. And this is the kind zero order. So where rate versus concentration, there is a straight line without any deviation. What does it mean? Rate of the reaction doesn't depends upon the concentration. It is the independent of the concentration and it will not be affected. That will be the zero order straight line. Rate is equal to Kx. And if you go for this kind of graph where pressure versus time were plotted and there is a curvature, you can clearly observe this is the right representation for instantaneous rate of the reaction. This will be the right representation. And for the first order kinetics, rate is equal to K into A. Rate depends upon the concentration of one unit of starting materials only, without applying any kind of logarithmic values. If we are directly plotting rate versus concentration, the straight line or the straight line originating from zero can be observed. This is the one which is represented with the y is equal to mx form. Y is equal to mx form will be always having the straight line passing through the origin. This is called a first order. Among all instantaneous rate, the exact representation will be option number C. For question number 2, option number C will be the correct answer. Move on to question number 3. This is the question collected from JEE Advanced 2023 question paper, and it is given from the colloidal solution. Right, colloids are nothing but these are the part of physical chemistry, and some of the assumptions are provided. We need to identify which will be the correct explanation for the given question. Fine. Leophobic colloids are not formed by simple mixing of dispersion phase and dispersion medium. For emulsions, both dispersed phase and dispersion medium are liquids only. Micelles are produced by dissolving surfactant in any solvent, any temperature. Tyndall effect can be observed from colloidal solution with dispersion phase having same refractive index as dispersion medium. From these, we need to identify which are the correct statements. Fine. So among all, only the correct are 1 and 2. We have to identify why 1 and 2. Right. For that purpose, let's go one by one. Leophobic colloids. Colloids can be classified into two types: leophobic, leophilic colloids based on the affinity towards the solvent molecules. If they are readily soluble in the solvent, those are called leophilic in nature. If they are hating solvent, those are called leophobic in nature, right? Solvent hating colloids are said to be leophobic in nature, where there is a little interaction with the solvent molecule. Dispersion phase and dispersion medium, these are also the kind of new terms we can say. Dispersion phase in the sense which is a little content, smaller content species in the given colloid. Dispersion medium is the larger content medium in the colloidal solution. Fine. So whenever these two are interacting, solvent reactivity, solvent affinity is very least. Those are called leophobic in nature. Leophobic colloids are having tendency to mix very little. That's why we need to add coagulating agents. They can easily coagulate it. They can easily precipitate it at the bottom. We can clearly observe. They can easily suspend it at the bottom. Fine. Gold sol is the simplest example for leophobic colloid. So whatever explanation they provided, exactly correct one only. They are not easily formed by mixing dispersion phase and medium. Some kind of external stabilizing agents can be mixed, then only they will become more stable. Fine. Next is about emulsion. Emulsion is nothing but colloids can be categorized into various types based on what their mixing of physical states of dispersion phase and dispersion medium. There are the possibilities of a solid liquid, solid gas, liquid liquid, liquid solid, liquid gas, gas liquid, gas solid. These many kind of possibilities we will get by taking different kind of physical physical appearance of dispersion phase and dispersion medium. Among all, emulsion is the kind of species. Emulsion is the kind of colloid where dispersion phase is a liquid, dispersion medium is also liquid. And milk is the best example for this emulsion, where dispersion medium is the water, dispersion phase will be the fat. Fat dissolved in water, both are liquids only. That's the reason why best example for emulsion will be a milk, and both are liquids only. That will be the correct explanation. Myceli. Myceli is the kind of species which is having bunch of molecules rather than individual. What they are saying, myceli is produced by dissolving surfactant in the solvent. One surfactant, one solvent may not be possible. Rather, it is the kind of aggregation of the particles. If you see the air, so many dirt particles will be there. Okay, individual monomers, if combined in such a manner, they're able to form a ball or bunch type of one, which is called a myceli. Right. So if we are applying soap on the dirt cloths, myceli kind of system is working so that dirt can be cleansed. Dirt can be easily cleansed with the soap treatment. Right. So this will be the myceli. And myceli is the kind of aggregation of particles rather than dissolving a solvent and surfactant molecules, so that it will not give the true sense. Fine. Tyndall effect. Tyndall effect is nothing but scattering of light. Okay, whenever dispersion phase and medium are coinciding together, light will be scattered with certain angle, and that scattered light able to form a layer around that one, so that visualization of particles, invisible particles, get visualized by Tyndall effect. Right. So what they are saying is, in case of Tyndall effect, dispersion phase particles and dispersion medium particles are having equal refractive indices. That is the not the correct answer, because in order to get the Tyndall effect, dispersion phase should have one kind of refractive index, dispersion medium is having another kind of refractive index values. So we have to understand what are the protocols for the exhibition of this Tyndall effect. There are certain rules are there. One is diameter of the dispersion particles much smaller than the wavelength of the light. Whatever light coming, its a wavelength intensity, its a wavelength must be higher when compared to the particles under the observation, right? So diameter of the dispersed particle should be smaller when compared to the light wavelength. That is the condition number one. And second is diameter of the dispersed particles not much smaller. Okay, if you are taking tiniest particles, when they are interacted, bombarded with the light, they may not becomes visible. There should be an optimal size. Certain extent of size should be there. Then only light, when irradiated on the surface of this particle, that becomes visualized, that becomes visible. Fine. So diameter must be optimum. Optimized size should be there. If it is too smaller, we can't see even under the irradiation of light. That means Tyndall effect may not be operated over there. Fine. And the refractive indices of dispersed phase and dispersion medium differs greatly in the magnitude. So this is the condition what they are asking actually. So both should be same, they are saying, but both should be different. That's why this is also not satisfied. Only option number 1 and 2 are exact answers for the colloidal solutions. They are given in the option number A. For question number 3, option number 4, A will be the correct answer. Move on to question number 4. In a question number 4, this is the question given from biomolecules. It stands for carbohydrates. Fine. A disaccharide X cannot be oxidized by bromine water. The acid hydrolysis of X leads to a levorotatory solution. The disaccharide X is, right? Disaccharide means any compound when added to water. That means hydrolysis gives two monosaccharides called disaccharide. It is very simple. And cannot be oxidized by bromine water. What is the tendency of bromine water? Bromine water is the mild oxidizing agent that can oxidize aldehydes and ketones into carboxylic acids, right? But this disaccharide is not in a position to get oxidized. That means what? It is a non-reducing sugar. Here only hint is given, that is a sucrose. Disaccharide non-reducing sugar will be maybe a sucrose. Right. The acid hydrolysis of X leads to levorotatory. When this disaccharide taken and dissolved in the water, whenever added to the water, that will be splitted. One of the component will be levorotatory in nature. It is obvious that among the monosaccharides known, fructose is a levorotatory, glucose is a dextrorotatory. Hence, we can say glucose is a dextrose, fructose is a levorotatory compound. Fine. So what will be the disaccharide given over here? Okay, so from this data, it is very clear that no compound is having free aldehyde or ketone, so that all are non-reducing only, right? So this point number 1 will not give any sense to solve this problem actually, because here cannot be oxidized by bromine water. So no compound is having free aldehyde or ketone. That's why we can't predict what is what. Okay, acid hydrolysis is giving one of the compound as a levorotatory. That means a fructose is given. So whenever fructose is coming, so that disaccharide most probably will be the sucrose, because if we observe all these, here furanose ring is provided, that will be the fructose only, no? So one is fructose, one is glucose. That compound will be a sucrose. Sucrose is a non-reducing. So condition 1 will be satisfied. And acid hydrolysis, one glucose molecule, one fructose molecule will be generated. One dextrorotatory, one levorotatory will be generated. Right explanation is provided. Let's go with this carefully. Sucrose is a non-reducing disaccharide. Non-reducing disaccharide because it is condensed molecule made up of glucose and fructose. Glucose and fructose are the constituent molecules for this one. They got joined by the glycosidic linkage. Whatever ether linkage we can observe among these two, it is called a glycosidic linkage. It cannot oxidize bromine water. Bromine water can't work upon this because no aldehyde or ketone existing on this. Ketone aldehydes are absent in order to oxidize. When sucrose undergoes acid hydrolysis, it will be broken into monosaccharides like constituent monosaccharides like glucose and fructose. Whatever constituents are there, they will be released upon hydrolysis. So that glycosidic linkage will be cleaved and glucose fructose will be generated. Among these two, fructose will be a levorotatory. Levorotation, dextrorotation means whenever compound is taken, plain polarized light is radiated on its surface, the compound able to rotate the light either right hand side or left hand side. If that light is rotated right hand side, dextrorotatory, rotated left hand side, levorotatory. The glucose will rotate right hand side, dextrorotatory. Fructose will rotate left hand side, levorotatory. Right? So that we can clearly assume for this one. For question number 4, option number A will be the correct answer. We will move on to question number 5. This is given in the Telangana State Council for Higher Education EAMCET examination in 2023. Let's go with the question first. The radius of first Bohr's orbit of the hydrogen atom is same as that of orbit N of hydrogen-like species. Okay. Radius of hydrogen Bohr orbit of hydrogen is known to everyone. Another compound is also there, that is X. The compound X is also having same orbit number, and what will be the species we need to identify. What species among the given options having same radius of first Bohr's orbit? Okay, of hydrogen. We need to predict that one. Hydrogen paramanu nandu మొదటి బోర్ కక్ష వ్యాసార్థము హైడ్రోజన్ వంటి జాతి X యొక్క కక్ష N వ్యాసార్థానికి సమానం. N మరియు X లు వరుసగా. ఓకే, ఈ రెండు వాల్యూస్ ను మనం ఫైండ్ అవుట్ చేయాలి. ఓకే, ఆప్షన్ నెంబర్ 1 lithium +2 is provided. Option number 2, lithium plus 2 with orbit number 3 is provided. Beryllium plus 3 with orbit number 2 is provided. Helium plus with orbit number 2 is provided. In order to find out the radius, Bohr's orbit radius, we have the formula R is equal to n square h square by 4 pi square mz e square, right? N denotes what? Here n is provided called the orbit. In which orbit electrons are revolving is called n value. H is the Planck's constant value, which is always constant. 4 is constant, pi is constant, m is nothing but mass. Z is nothing but atomic number. Z value is the atomic number. E denotes what? Charge of the atom provided or ion provided. Fine. So if you are taking neutral atom, charge may not be present. Okay. So for hydrogen atom, first of all, we have to calculate. It is the simplest atom among all the elements in the periodic table. So that we will start with this. Right. So if you calculate radius is equal to n, that value for n value, orbit value is provided as 1 only, 1 square will become 1 only. That's why h square by 4 pi square m square. If you substitute all known values in this formula, it is calculated as 0.529 angstroms. This will be the hydrogen radius of first Bohr's orbit. Fine. So whatever any other options are provided, they should map with this one. We will see one by one. If you go with lithium plus 2, apply the same formula. 0.0592 into its orbit number is provided as the 3. Orbit number is 3, no? So that you can write a 3 square by 3. 3 means what is Z? Atomic number is taken as Z. And if you substitute all these values will be 1.587 angstroms. Thus radius 1.587 may not be exactly same as hydrogen. So we can cancel out. Move on to another option, beryllium plus 3. For beryllium plus 3, atomic number is 4. Second orbit can be taken. Charge will be plus 3. If you substitute all the values, it is calculated as 0.529 angstroms. After the calculation, radius is provided as 0.529 angstroms. It is exactly mapping with the hydrogen. The whatever question they are asking exactly satisfied over here. The radius of first Bohr's of or orbit of hydrogen atom exactly similar with this beryllium plus 3 and its orbit number is taken as 2. This will be the correct answer. Let's solve for helium plus as well. For that purpose, atomic number is taken as 2. Third orbit n is equal to 3 will be provided. Orbit number 3 will be there. Substitute all the values. It is calculated as 2.380. Is there any relation? No relation. So that we can say hydrogen and beryllium plus 3 both are same with the orbit number 2. For question number 5, option number C will be the correct answer. Move on to question number 6, last question of today's session. Identify impossible quantum number set for the electron from the following. ఈ క్రింది వాటిలో ఏ క్వాంటం సంఖ్యల సమితి ఎలక్ట్రాన్ కు వీలు కాదు. Okay. So here quantum numbers are very important in order to construct molecular orbitals in the given molecules. In order to form the molecule from the atom, quantum numbers plays a vital role. Based on quantum numbers only, there are certain principles that are provided like Auber principle, Hund's rule, Pauli's exclusion. They mainly plays on these quantum numbers only in order to explain how to fill molecular orbitals conveniently. Okay, which is not satisfied. Among all are correct except one. That will be option number C. We have to calculate, we have to identify why option number C is not correct. Let's see. First of all, what are quantum numbers? Quantum numbers are 4, denoted with N, L, M, and S. Here it will be S. Principal quantum number is called small n, whose values are ranges from 1 to 3, 4 in an increasing order. And azimuthal quantum number, principal quantum number explains how distance the orbital is from the nucleus and what is the energy of that orbital. Both can be size and energy can be explained by principal quantum number. And second is about azimuthal quantum number. It will give in which direction orbital is oriented, or orbital orientation can be explained. The size, the shape of the orbital can be explained by azimuthal quantum number. If s orbital is there, that is the spherical in nature. P orbital is there, dumbbell in nature. D orbital, double dumbbell in nature. So in this manner, orbital shape can be explained with the azimuthal quantum number. Always values are ranges from n minus 1. If n is equal to 3, always L value will be 2 only. Means n minus 1 value will be assigned for azimuthal quantum number. Magnetic quantum number means its orientation, in which coordinate the orbitals are laying, x direction, y direction, z direction, on which direction orbitals are laying, can be explained with the magnetic quantum number. That will be small m. Values ranges from minus L to plus L, including 0. Minus L, 0, plus L values are given for magnetic quantum number. And another is about spin quantum number, given with a small s. The values are plus half and minus half. All these about the quantum numbers, which is not correct exactly, we have to identify. For that purpose, let me take n is equal to 3. If n is equal to 3, L value must be 2 only, because L value always n minus 1, no. That's why we have to substitute 3 minus 1. So value will become 2. Then n is equal to 3, the L value must be 2 only. For this L value, the magnetic quantum moment numbers values are minus 2, minus 1, 0, plus 1, plus 2 should be there. And spin quantum number will be plus half and minus half. This is the right representation. But what they are saying, n is equal to L is equal to, both the values are same. This never happens. That's why absolutely wrong statement will be option number 3. For question number 6, option number 3 will be the right answer with a wrong representation. By this, we entirely completed the session. I'm sincerely requesting like the channel, comment if you are really interested about this one, which part is most interested for you. If any kind of explanation, you can comment over here and share with aspirants who are seriously preparing for the examinations like entrance or competitive exams. Subscribe the channel in order to get more future updates, in order to get more such kind of content, valuable content, we can say. Thank you very much for your patient listening. Thank you one and all.